Hello and welcome again to WinHEC. I feel like I was just here. The last presentation I talked about the amazing technologies we've delivered with NICs in Windows Server and high-speed Windows workstations. But now we need to look at the fact that the model of the driver framework that we're using today, NDIS, NDIS, is old. It is. It's getting a little bit harder to do things because it was designed back in the days when NICs didn't go very fast. So today we're going to talk about a new model, a new driver framework that's coming. And we're going to tell you how you can start to be involved with that new networking driver framework now and how you can help us shape it so that it meets your needs going forward. That's what today is about. We're going to talk about what NetAdapter is about. We're going to talk about the architecture, some real-world things, and now we're going to talk about how you can partner with us on it. So what is it? How many of you are familiar with the Windows driver framework? If you write drivers for Windows today, except for networking, you're probably using the Windows driver framework. There are thousands of drivers out there now built to the Windows driver framework. And the Windows driver framework team knows how to deliver a good driver framework. But for the last 15 years, networking has been delivering a different framework. We need to come up with a way to get into the productivity and performance that Windows driver framework can provide while keeping enough of the current NDIS technology to deliver the performance, the 100 gigabit per second performance that we see today with NDIS. So, we're going to start talking about how you do this. People came to us and said, we've got a problem. I want to be able to use WDF to manage things like my power, my P&P interactions. They want to be able to do all kinds of things with USB buses. I want to be able to do the things that I can do for my other kinds of drivers, and I want to do it for networking. But we don't have a way today to do that. That's changing. So, today, we spend a lot of time troubleshooting situations. In fact, one of the biggest things we have to troubleshoot, because it's so complex, is power management. As we go into suspend and back out, as we go to low power states and back to full power states, we've discovered this is very, very difficult for driver writers to manage. So we are coming up with a way with the WDF team to do an extension to the WDF class model that provides a way for the Windows driver framework to take over all of that. Resources. Today, when we go to free a resource, and you have to walk down the chain and free up all the associated resources, just leave it to the Windows driver framework. It will clean up all the other resources involved. We have a bunch of new OS features coming along. We can come up with more extensions to end this, or we can let the Windows driver framework just do it. And eventually, we're going to want to move into user space and move drivers to user space. The Windows driver framework model easily can be moved to user space, while the NDIS model does not. So, why NetAdapter? Less development, less complexity, less maintenance, because if it's easier to write, it's easier to debug, it's easier to maintain, and has less bugs to begin with. Finally, we heard from all of you that it's very, very hard to find developers who know how to program to the NDIS model. But there's a lot larger pool of developers who have WDF experience, Windows Driver Framework experience. And so, in order to help you find quality driver writers, it helps if we move to the model that your driver writers are used to using. Finally, as we mentioned in the last talk, we've gone to having NICs that went from being single queue to mini queues, from 100 megabits per second and slower to now 100 to 200 gigabits per second. The driver framework that those original NDIS calls were made for just aren't suitable anymore. We need a new model that can handle the incredible capabilities of the new NICs. So, that's pretty much it. The biggest issue is making it easier and safer and better to run. 9F bug checks are very common today. With the WDF model, it should be almost impossible to get to a 9F. The 133 bug check, the running out of DPC timeouts. Again, your NIC shouldn't have to worry about that. That should all be done in the OS. And with the Windows Driver Framework model, it will be. So, what are the principles we use to come up with NetAdapter? The first one's really the most important one. Doing things the right way should really be easy to do. Doing things wrong should be hard. It should just be natural to do things in the right way, to make it easy for you to develop your NIC driver. We want to be consistent with the Windows Driver Framework so that all of the skills that your driver writers have from writing other Windows Driver Framework drivers port automatically to developing network drivers. And we want a very, very fast, reliable data path that's very close to the metal, very close to the hardware, so that we can get all of the performance that we need when we're processing packets at hundreds of gigabits per second. So, if we're 100% compatible with the network stack, all the user mode apps, the existing NDIS APIs, and the universal driver model, we all heard about DCHU, that's very important to us, then we'll be getting close to where we need to be. Okay, we've talked about most of these already. A simple model, easy to use and reuse the same skills that your driver writers who've written other kinds of drivers for Windows already have. Rich debugging, good verification, and no more use of this very special silo, this very closed box called NDIS that locks everything into only one way of doing things, and it's a complex way. In the traditional model, everything you did came through NDIS, even some of your communications with your hardware. All the PNP calls, all the power policy and power management, the data, all the OIDs that came down. Oh, OID handling. How many of you enjoy doing that? Not too many, I suspect. So what are we going to do? We're going to break it apart and let the Windows Driver Framework surround your NIC. It will take care of all the PNP, power policy, and power operation. It takes care of doing all that, and we extend it with a class extension called NetAdapter, so that now when OIDs arrived, they come as a WDF object. And it's this plain, same kind of object handling that you do for everything else in WDF. Data path, it's coming in also just directly to your driver. NDIS is still there. That means all the lightweight filters, all the protocols, everything of NDIS are still there. But your driver doesn't have to worry about them. It has a simpler interface. It wouldn't be any good if we built this new interface and it didn't work, would it? In fact, we know it does work. Our good friends at Realtek, just down the street, over the hill a little ways, worked with us very closely, and we appreciate them a great deal. We took one of their 1 gigabit per second devices, and we wrote a NetAdapter model driver for it with their help. And they have been very helpful to us in the collaboration to get this done. So for the Realtek chipset, we went along a typical standard chip, typical standard driver that they had. Has checksum offload that we talked about last time. It's got wake on LAN, the ability to come back and wake up the OS when the right packets arrive. And what happened? We ended up with half the lines of code. That's a pretty good savings, I think. The transmit and receive handlers have no spin locks. That sure cuts down some of the complexity and performance and places where bugs can come in. No ref counts, no linked lists, no asynchronously operating code, and no pauses. There's even ways in which local DMA can be bypassed with our I/O-assisted helpers. We took a USB adapter from another company. We ported the driver, a USB 2.0 chipset, 100 megabit per second dongle. I'm sure you've all seen those kinds of devices around. Wake on LAN, AOAC, all the standard kinds of functionality are there. And we rewrote the entire data path in 400 lines of code. Now, that's a pretty good savings. And that includes a power-managed data path. Again, no spin locks, no interlocks, no DPCs, no work items, timers, context, or memory allocations were required because the Windows driver framework takes care of all of that for us. So, how does this affect you? You're the reason that we're here. You're the reason we're creating this new model, because if we didn't need you to develop new drivers for new NICs, we wouldn't have to change anything. So, first of all, let me reassure you, NDIS isn't going away anytime soon. It's going to be here for a long time. And we're going to continue to evolve NetAdapter to grow it into more and more functionality. New features are still going to ship in NDIS. NetAdapter is not ready to take over the world. And you can still build, certify, and ship NDIS drivers. NDIS tests will still work. All the things you're used to in the familiar environment are still there. So, nothing's going away yet, but we're offering you an alternate path that will be easier and simpler. The biggest message is, it's not design complete yet. We're still working on it. And this is where we really, really, really need your help. Because you see, we have ideas about what NIC drivers need, but we don't know all of your NICs. We don't know all your plans. We don't know what things you might want us to enable on your hardware. So, we decided on an open source, open development model for the new framework. It's up on GitHub. Are you familiar with GitHub? I hope. So you can get on and you can see all the work we're doing. You can download it. You can play with it. And we're going to do some very close collaboration with a few selected vendors. If you think you want to be one of those, let me know. And we're going to be going for a long time. NDIS 6 is going to still continue while NetAdapter continues to mature. And things like server-class Ethernet NICs, WLAN, mobile broadband, and user mode are all going to be coming later on. They're not there yet. What have we got today? Well, today we have our Realtek driver. We have the portions of the OS that we need. NetAdapter translator, and the NetAdapter class extension. We have in progress a mobile broadband driver and a Wi-Fi driver. I heard that the mobile broadband driver is actually passing packets now. Our dev team has been playing with it, and we're getting there. I expect to see it coming along fairly soon. But we're not all the way there. So, because we haven't completed design for all the capabilities that we need to have in NetAdapter, we're not yet API stable. So if you were to try to build something to ship today, you'd be taking some risk. But we still want you to start looking at it. We want you to start playing with it. We want you to start giving us feedback on what we still need to do to make your NICs the most capable that they can be. The current sample and the current shipping code has not been performance tuned. We're getting good performance, but we're not getting the performance we expect we will get once we get in and do some tuning. All those things I talked about last hour, RSS, LSO, VMQ, RSS, VMMQ, RDMA, all those kinds of things, they're not in there yet. But they'll get there. And we need to go to multiple queues. The current sample that's up there supports a single queue. But as we saw last hour, we're now talking about NICs that need 1,000 queues or more. And buffer management hasn't yet been developed. Obviously, as we start spreading to multiple queues, we're going to need better buffer management. So these are things we still need to do. So, again, we need your help. We need you to download and review the sample. Give us feedback. Look at the source code. Tell us what we did well. Tell us what we didn't do well. Tell us how to improve it. Make suggestions. As you're probably familiar with GitHub, you can upload your suggestions. You can upload corrected code, and we can look at it and check it in. Tell us what we need to do to light up the capabilities of your NIC. So we hope your next driver, your next new hardware coming along, will use NetAdapter. Why? Because the Windows driver framework is productive, is feature-rich, and we're getting there with NetAdapter, so that networking will be fully able to take advantage of the Windows driver framework. NetAdapter is built for speed. The data path has been optimized for some incredible speed for these future NICs that we know are coming down the pipe. And we are doing it because we heard from you that the current environment is too complex, and it's too hard to find people who can work on it. Where can you get more information? Well, we have this wonderful website. You can go there. It's got a whole bunch of things on it. When you go there, you're going to see 4 videos. The first video is a much better presentation of what I've just told you. And then there are some in-depth technical things that look at how the data path works and how you program it, how you can make use of the WDF already for your simpler NICs. The documentation is there, and of course, is continuously being improved. Like anything in the open source environment, it's going to be continuously updated, continuously improved. Tell us what it needs to have. Driver samples are up there, and the source code of NetAdapter itself, actual Windows source code, are up there on GitHub for you to download and look at and give us feedback. So, what's the message? Go to this site, look at the videos, look at the sample documentation, look at the sample code, look at the NetAdapter extension code, and give us feedback. That's what we need from you. And I'll be available at the Ask the Expert session. If you have any questions on this, please feel free to look me up. Otherwise, just send me email, donstamwick@microsoft.com, and we'll make sure that we help you through this. Thank you for your time today.